Your European customers are getting 200 millisecond latency while your US users get 20. And you just got a GDPR compliance notice because EU user data is being processed in Virginia. This one Route 53 configuration could have prevented both problems.
Okay, that sounds serious. Welcome back to the Network Ninja Cloudcast, everyone. I'm really curious about this one because I've been struggling with exactly this kind of multi-region setup.
Great to have you here. Today we're diving deep into Route 53 geolocation routing, and I promise by the end you'll know exactly how to route traffic based on where your users physically are, not just where they're closest to.
Wait, isn't that what latency-based routing does? I thought that already handled regional traffic.
That's the number one misconception I see. Latency-based routing sends users to the fastest endpoint, but geolocation routing sends users to a specific endpoint based on their geographic location, regardless of latency. Think of it like this. Latency-based is like GPS navigation finding the fastest route to any grocery store. Geolocation is like your company policy saying employees in Germany must use the Berlin office, period, even if the Munich office is faster to reach.
Oh, so it's about control and compliance rather than just performance optimization.
Exactly right. And this matters hugely for three scenarios. First, data sovereignty laws like GDPR requiring EU citizen data stays in EU regions. Second, content licensing where you can only serve certain media in specific countries. Third, localized experiences where you want users hitting region-specific application versions with local pricing and language.
So how does Route 53 actually know where a user is located? Is it using their IP address?
Yes, Route 53 uses a geolocation database that maps IP address ranges to geographic locations. When a DNS query comes in, Route 53 looks at the source IP of the DNS resolver, not the end user directly, and matches it against this database. You can configure records at 3 levels of granularity: continent, country, or for the US and Canada, down to the state or province level.
Hold on. You said it looks at the DNS resolver's IP, not the user's IP. Doesn't that cause problems?
You caught something important. If someone in France uses a US-based DNS resolver like Google's 8.8.8.8, Route 53 might think they're in the US. However, most modern resolvers support eDNS client subnet, defined in RFC 7871, which passes a portion of the client's IP to authoritative DNS servers. Route 53 supports this, so it can make more accurate decisions. But you should always configure a default record as a fallback.
Okay, let's get practical. How do I actually set this up in the console?
In the Route 53 console, you create a hosted zone for your domain. Then create record sets with the routing policy set to geolocation. For each record, you specify the location. Let's say you have an application load balancer in EU West 1 with DNS name myalbu.eu-west1.elb.amazon.com. You'd create an A record, enable alias, point to that ALB, set routing policy to geolocation, and set location to Europe. Then repeat for your US ALB with location set to North America or specific countries.
What happens if someone queries from a location I haven't configured, like Australia in your example?
This is critical. If there's no matching geolocation record and no default record, Route 53 returns no answer, and your users get nothing. Always create a default record. In the console, when setting location, choose default instead of a specific geography. This catches all unmatched locations.
That seems like an easy mistake to make. What other gotchas should I watch for?
The biggest mistake I see is overlapping records without understanding precedence. Route 53 uses most specific match-whens. So if you have a record for Europe and another for Germany specifically, German users hit the Germany record, not the Europe one. I've seen teams create a Europe record expecting it to cover Germany, then wonder why their Germany-specific record is getting all German traffic.
So the hierarchy goes state or province, then country, then continent, then default.
Precisely. And here's a pro tip for compliance. If you're implementing GDPR data residency, don't just route traffic geographically. You need to verify your backend actually processes and stores data in that region. Geolocation routing is one layer, but your application architecture, database replication, and logging all need to align. Route 53 gets users to the right door, but what happens inside is your responsibility.
Let me make sure I've got this. Geolocation routing is about control and compliance, not performance. It uses IP-based location detection with eDNS client subnet support. I configure records per geography with most specific winning, and I must always have a default record or users get nothing.
Perfect summary. One final tip. Use Route 53 health checks with your geolocation records. If your EU endpoint goes down, You can failover to another region rather than returning no answer. Combine geolocation with failover routing for production-grade resilience.
This is really practical. I'm going to set this up in my AWS console today for our staging environment.
That's exactly what I want to hear. Start with staging, test from different geographic locations using VPNs or services like DNS Checker, and verify your default record catches edge cases.
Thanks for breaking this down. Everyone, if you're dealing with multi-region compliance requirements, share this with your team.
Thanks for watching the Network Ninja Cloudcast. Go configure those geolocation records, and we'll see you in the next one.